Today we're on day 5 of section 5.1, verifying identities, and today we're going to talk about the strategy of working with both sides. So for our first example, we have cosine squared of x plus 4 cosine of x plus 4. This is all over cosine of x plus 2, and this is equal to 2 secant of x plus 1 over secant of x. So today we're going to talk about the strategy of working with both sides. So what that means is we're going to work with the left side, get as far as I can, and then we're going to start working with the right side to see if I can make them end up being the same result. So with the left-hand side, in the numerator, we could factor this, so if it helps, think of it as x squared plus 4x plus 4. So my two numbers then multiply to be 4 and add to be 4 would be 2 and 2. So you can kind of think of this as factoring down to be x plus 2 and an x plus 2. So to kind of like tie this back together, up here, this means it factors down to being cosine of x plus 2 times cosine of x plus 2. And this is all over cosine of x plus 2. So one set of these is going to cancel, but I'm going to still be left with cosine of x plus 2. And here's where we kind of hit the wall. I have everything in terms of sine and cosine. I only have two terms. I don't have much to do with it. So now we're going to work with the right-hand side. On the right-hand side, we could separate this into two fractions, so I'm going to kind of pull this apart. So I would have 2 secant of x over secant of x plus 1 over secant of x. So the secants are going to cancel and I'll be left with 2, and I know 1 over secant is cosine of x. So when we get to this point where I've proven that they can be changed to the same thing, I can now say that the identity is verified. So we're going to do another problem where we work with both sides. So for our next example, we have 1 over 1 plus cosine of x plus 1 over 1 minus cosine of x. And this is equal to 2 plus 2 cotangent squared of x. So working with the left-hand side, we have to get common denominators. So we're going to multiply both sides by the denominator. So this left-hand fraction is going to be multiplied by 1 minus cosine of x, top and bottom. And this right-hand fraction is going to be multiplied by 1 plus cosine of x, top and bottom. So this fraction will turn into being 1 minus cosine of x. In the bottom, when I FOIL, I'll have 1. My inner and outer are actually going to cancel because I'll have minus cosine and a plus cosine. So they're gone. But the negative cosine times the positive cosine will be minus cosine squared of x. Okay. Now my other fraction, I will have 1 plus cosine of x. And in the denominator, again, I'll have this 1 minus cosine squared of x. And the whole purpose of getting common denominators is so I can put these together. When I add this together, then my numerators, I have a negative cosine and a positive cosine, so they're going to cancel out. And I'll be left with 2 over 1 minus cosine squared of x. And I know 1 minus cosine squared is actually sine squared, so 2 over a sine squared of x. So we're going to pause here, and now we're going to kind of work with that right-hand side and see if I can try and make this right-hand side become 2 over sine squared of x. So I'm going to go to the different screen so that I can have more room. So remember that the goal is I'm trying to make it become 2 over sine squared of x. So I have 2 plus a 2 cotangent squared of x. So I'm going to start with the basics of getting everything in terms of sine and cosine. So I'll have 2 cosine squared of x over a sine squared of x. I can put this over a 1, so I'm going to have to get common denominators. So I'd be multiplying this fraction by sine squared, top and bottom, to get the common denominator. So it will become 2 sine squared of x over sine squared plus 2 cosine squared of x over a sine squared. And the whole purpose of getting common denominators is to put this together. So I'll have 2 sine squared of x plus 2 cosine squared of x. And this is all over a sine squared of x. In the numerator, I have a GCF, so what they have in common is a 2. So I'm going to factor that 2 out. So I'm left with sine squared plus cosine squared. Oops, I'm missing the plus sign. So I use sine squared of x plus cosine squared of x. And this is all over sine squared. And I know sine squared plus cosine squared is equal to 1. So this is going to kind of cancel out and become 1. And 2 times 1 is 2 over sine squared of x. So at this point, we can kind of say that our identity is verified because I got 2 over sine squared of x for both sides. So that is kind of our last strategy that we're going to talk about in section 5.1. So that's all for today. We'll talk about this tomorrow.